Okay, so today we will discuss general Fibonacci sequence if n plus 2 equal to a times if n plus 1 plus b times fn, where a and b are positive numbers. So there is a general question to ask: is there any closed form of fn for all n? The answer is yes. So I will show you a trick how we can find the general solution. So consider the series is hx defined by sum over n from 0 to infinity fn times x to the power n divided by n factorial. So now take the first derivative, check that d dx of hx equal to summation n from 0 to infinity fn plus 1 x to the power n by n factorial. And also check that d2 dx2 of hx equal to summation n from 0 to infinity fn plus 2 x to the power n by n factorial. So now we have by our condition if n plus 2 equal to a if n plus 1 plus b fn, we have d2 dx2 of hx equal to a times d dx of hx plus b times hx, because as we assume the recurrence relation is if of n plus 2 equal to a times fn plus 1 plus b times fn. Yeah, so the general solution, we want to find the general solution of the second order linear differential equation. So we all know the technique that we have to solve some quadratic equation. The quadratic equation by this second order linear differential equation is r square minus ar minus b equal to 0. The roots of the equation is a plus minus root over a square plus 4b divided by 2. A square plus minus root over, yeah. So the general solution of this differential equation is hx equal to c1, some constant, e to the power a plus root over a square plus 4b divided by 2x plus c2 times e to the power a minus root over a square plus 4b divided by 2x. Yeah. Yeah, so the general solution of this differential equation is this c1 times now e to the power a plus equate the coefficient of x to the power n both sides. So solving this differential equation means solving for yx, and yx is hx by definition. So equating the coefficient of left hand side, which is x to the power n of left hand side, is fn by n factorial, and coefficient of x to the power n on the right hand side is this plus c2 e to the, yeah. So we all know the c is expansion for e to the power x. So what is fn then? Fn is c1 dot a plus root over a square plus 4b divided by 2 power n plus c2 times a minus root over a square plus 4b divided by 2 power n. Yeah. So if you put n equal to 0, we have f naught is c1 plus c2, and if you put n equal to 1, you got c1 times a plus root over a square plus 4b divided by 2 plus c2 times a minus root over a square plus 4b divided by 2. So the point is you can calculate c1 and c2 by solving these equations. Yeah, in terms of f0 and f1 and a and b. So the general formula for fn is this, where c1 c2 can be computed by solving these equations. So there is a nice application. So there is a nice application to this formula. So let us define the original Fibonacci sequence, defined by f0 is 0 and f1 is 1, and fn plus 2 equal to fn plus 1 plus fn. So the general term fn is, as we showed before, with a and b are both 1. A and b are both 1. So 1 plus root 5 by 2 power n plus c2 times 1 minus root 5 by 2 power n. So f0 is just putting n equal to 0, c1 plus c2, and f1 is c1 times 1 plus root 5 by 2 plus c2 times 1 minus root 5 by 2. Now just solve this equation. c1 plus c2 is 0 as f0 is 0. And c1 times 1 plus root 5 by 2 plus c2 times 1 minus root 5 by 2 is 1. So we have just putting c2 equal to minus c1, we have c1 equal to 1 by root 5. Just simple calculation by root 5, and c2 equal to minus 1 by root 5. Okay. So the general term is 1 by root 5 times 1 plus root 5 by 2 minus 1 minus root 5 by 2 times 1 by root 5, means the general term is 1 plus root 5 by 2 power n minus 1 minus root 5 by 2 power n by root 5. So next time, this is the general solution. So next time we will discuss about phi n, the Euler-Tauschent function, which is defined by phi n equal to n times product p divides n1 minus 1 by p, and some interesting properties of this guy, with some interesting properties. So thanks for watching.